So now you have that opportunity. So we kept this up here. You can go back through, if you wrote this down, so now you can see how these problems are worded and go back through the calculations that you did. Okay, so now the problem in blue and purple here, okay? If we're starting with 37 grams of this amino acid called glycine, we picked, what was it, oxygen? Okay, so upon doing this, we would start with 37 grams, and I'm just going to put GLY, because that's the abbreviation for this amino acid known as glycine. So just like everything that we've done so far, you see something measured in grams, chances are you're going to change it to what? And this is a discussion that we had earlier, and I didn't mention it yesterday. I should have. It was International Mole Day, the measurement moles, because when you write that out, what is the number for Avogadro's number? 6.022
times 10 to the
23rd. So when we look at that, the power of, or the 10 was the month, and then the exponent 23 is the day. That's what makes yesterday International Mole Day. Okay, so the next thing you need to do is find out what is the atomic mass of this amino acid glycine. So here you have to do a little bit of the organic chemistry that you did in the past. Okay, so how many carbons do we have?
75.02.
Okay, and chances are that's right, but we're going to double check anyway. We have 2 carbons, right?
Yes, sir.
Okay, at 12.01 each. Okay, so then that's where the 24 comes in. And like you said, 1, 2, 3, 4. The reason that these get to be a little tricky is because when you start talking about acids, you have oxygens in separate spots and hydrogens. Sometimes it is so easy to forget that last hydrogen. That's why we're going over it. Okay, so you said 5, 1, 2, 3, 4, 5. So 5.05.
Yep, 32.
Okay, and then we've got these 2 oxygens, 32, and there's one more number, 14.01. Oops.
75.0
Okay, so I'm going to double check. No offense, because how do you farmers? You do your own dilutions in your spray, right? Or you just have the agronomist do that for you?
Calculate up them ounces, man.
Right, so there is some pertinent information for this, right?
Well, yeah, you just calculate how much you need and then you put it in there.
Seems like kind of like what we're doing right here, aren't we?
That's enough. But this is
Yeah.
glyphosate. I want some glyphosate. You know what I mean? You know what I mean? I assume this is not.
And this is probably what you said. I get 75.08. Okay? This is grams of glycine. So every time we reach 75, how many moles of glycine do we have? Right. You get 1 mole of glycine. These have canceled. You're in moles. This next step is so important. Why?
Because you have 2 oxygens.
Okay, so for every mole of glycine, we want to cancel that out. The reason that this is so important is because every time you show your labels here, you know exactly where you're at. Okay, because I'm just speculating. Some of you ding-dongs at home doing homework, you're doing this, and then all of a sudden you're punching something on your calculator, all of a sudden your phone goes ding. Well, we better go check that phone. Might be important. I don't know. I'm just speculating. Okay. So then, for every mole of glycine, how many moles of water do you have?
2.
Why is it 2?
Because there's 2 of them.
Because there's 2 of them right here. Okay? Get 2 moles. Okay? Now,
Mole and then 16.
You got to put moles on the bottom.
Put 2 mole, man.
Moles of what? Because that's what we're dealing with, right?
16 grams of oxygen.
Now, one of the things that's going to happen, okay, you're going to have to be able to make this transition, is that every time we deal with oxygen, a halogen, nitrogen, and hydrogen, they're always going to be this term when they're by themselves. Starts with the letter D. They're diatomic, okay? So you could look at it this way, saying oxygen is diatomic, but for our purposes, we want you to be in this practice because when you do reaction stoichiometry, you have to go back to your mole ratio. This is just composition stoichiometry, composition of one substance. In this case, it's only glycine. Okay? So once you get this done, you multiply across 32 times 37, and we get what? 118.4. No, that doesn't seem right.
I think it's like a 1,182.
Yeah, 1,184. Okay, divided by this here. So then 15.77. Okay, and then that is grams of oxygen. Now, one of the things that another discussion that we had earlier. I don't have my glasses on. So is that not correct, somebody? That's what you got? Okay.